All right, so from your sheet, you had 9, 10, 13, and 14. So number 9 says a projectile is shot from the edge of a roof of a building that is 50 meters high. The muzzle velocity, which simply means what it leaves the gun with, so is 80 meters per second. And the angle is 40 degrees. And it wants to know the distance from the base of the building, the delta dx, and the velocity with which it hits the ground, so the VF, which means eventually we're going to need the VFX and the VFY. Okay, so in the x direction, we have VIX is VI cos theta, and we can get that number because they gave us both the VI and the theta. We know AX is 0. We're looking for delta dx. And we don't know delta, whoops, that's a t. And eventually we want a VFX too, but okay. In the y direction, VIY is VI sine theta. And again, we know this value, it's up. AY is 9.81 meters per second squared, it's down. We know delta dy is 50 meters, and it's down. We don't know the time. So it's a non-ground to ground. We're going to start like we have before with the quadratic to find the time. So delta dy is equal to VI sine theta delta t 1/2 AY delta t squared. So negative 50 meters equals 80 meters per second sine of 40 delta t plus 1/2 negative 9.81 meters per second squared delta t squared. Again, bring the terms over to the left-hand side. So positive 4.905 meters per second squared t squared minus, now 80 meters per second sine of 40 is 51.423, and I left that in my calculator. Delta t minus 50 meters equals 0. So delta t equals that 51.423 meters per second squared minus, oh, that's not squared there. Sorry, I did that again. It's the negative. In here it's squared. Negative 51.423 meters per second squared minus 4 times 4.905 meters per second squared. And it's not a minus, times minus 50 meters. Okay, and then it gets divided by 2 times 4.905 meters per second squared. So delta t equals 51.423 meters per second minus, under the square root, you're going to get 3625.52 meters squared per second squared. And then that's going to be over 9 point, that's plus or minus, 9.81 meters per second squared. So delta t is equal to 51.423 meters per second plus or minus 60.21 meters per second over 9.81 meters per second squared. So delta t is equal to 51.423 meters per second plus 60.21 meters per second over 9.81 meters per second squared, or delta t is equal to 51.423 meters per second minus 60. Now obviously this minus 60 is going to give us a negative time, so it cannot be this one. It has to be the first one, and when you do it you get a time of 11.38 seconds. Okay, so then you take that back to your delta dx and do VI cos theta delta t plus the 1/2 AX delta t squared term that goes to 0. So delta dx is equal to 80 meters per second cos of 40 times the 11.38 seconds. And you should get a delta dx to be 697.4 meters. So that's part A. Part B wants to know VF. So you need your VFX and you need your VFY to get your VF and your theta. VFX will be easy because it's just equal to VIX. So it's equal to 80 meters per second cos of 40. So VFX is 61.284, I think that is. I can't see, but I think meters per second. Now, VFY. Maybe the easiest way to find VFY is VFY squared is equal to VIY squared plus 2AY delta dy. VFY squared is equal to, that was 51.423 meters per second squared plus 2 times 9.81 meters per second squared times negative 50. And when you do this, you get VFY squared before you take the square root to be 3,625.52 meters squared per second squared. And you take the square root and get VFY to be 60.21 meters per second. And I'm hoping that you might recognize this as this number. What's under the square root is actually your VF. The discriminant of your square root will always, always, always be your VFY. And then once you have that, you square them, you add them together, you take the square root, and you should get 85.91 meters per second, and the angle is going to be really close to 45 because they're almost equal. So at an angle of 44.49 degrees WRT ground. Number 9, finished. Number 10 says fire hose something at the ground. There's a typo there. Near the ground. Shoots water at a speed of 7.5 meters per second. All right, so it's a ground to ground, and the VI is 7.5 meters per second. It's going up. It's coming down. It's telling you that it's landing 2 meters away. Delta dx is 2 meters, and it wants the angle. So x direction, VIX is equal to VI cos theta. We don't have theta. AX is 0. And delta dx is 2 meters. Y direction, VIY. VI sine theta, still don't have theta. It's going up. AY 9.81 meters per second squared down. And we can use our little trick of looking at just up to do AY is equal to VFY minus VIY over delta TU. This goes to 0. So TU will be negative VI sine theta over AY. So delta T total will be negative 2VI sine theta over AY. And then we're going to take this and we're going to fill it into our delta dx is equal to VI cos theta delta t. And the second term goes to 0. So we'll have delta dx is equal to negative 2VI sine theta. I didn't want to fill it in there. Excuse me. VI cos theta. Okay, let me do that over here. Delta dx is equal to VI cos theta delta t. All right, so delta dx is equal to VI cos theta bracket negative 2VI sine theta. Sorry, I was thinking I was doing the tan theta thing over AY. So bring your